Okay, so today we're starting our notes on LCM, which stands for least common multiple. And I just got done telling you guys the reason least common multiple is important is because when we start adding and subtracting fractions, you have to be able to find a common denominator. And it's best if you can find the least common denominator, which is actually the least common multiple of both of the denominators. So we're going to talk about how to find the LCM. You're going to hear me say that a lot. So to find the multiple of any number, we skip count. If I want to find the LCM, the least common multiple of 6 and 8, I'm going to skip count by 6s to figure out all my multiples of 6. And then I'm going to skip count by 8s to figure out all my multiples of 8. So I'm just going to go through the first 10. So I'm going to list my first 10 multiples of 6. So I'm going to skip count 6, 12, 18, 24, 30, 36, 42, 48, 54, and then 60. Then I'm going to skip count. I'm going to do the same thing for my 8s. I'm going to list out all of my 8 multiples. So 8, 16, 24, keep counting with me, 32, 40, 48, 56, 64, 72, and then 80. Okay, now we're going to look for the common multiples. So out of the first 10 that I listed for each of my numbers, I can see that I have 24, and I also have 48. So the M in the MCL, that's kind of like our steps. Instead of having step 1, step 2, step 3, it's just a quick little acronym thing to help you remember. So M, list your multiples. C, circle the common or the same multiples. So that's what we just did for the C. Now I want to focus on the least. So I'm going to find the least, which is what? 24. Yeah, if I kept going, then yes, it would. But I want to focus on the least common multiple. So finding the LCM is really important when comparing and converting fractions. So if you look at the first one, I have 1/8 plus 1/6. So this is kind of what we've been practicing and working on in our bell ringers the last couple weeks, is adding and subtracting fractions with unlike denominators. So if you see these fractions, you know I have to find an LCM of 6 and 8, these two. Well, we just figured out that 24 is my least common multiple. So that's going to be what I use as my denominator. So I'm going to put 24 here, and I'm going to put 24 here. Now, how did I get from 8 to my new denominator, 24? What did I multiply by?
By 3.
By 3. So I'm going to do times 3 for the denominator. But remember, anything I do to the denominator, if I multiply the denominator times 3 to get 24, I have to also do the numerator times 3 to get my numerator. So that's going to be 3 over 24. Now looking at my original fraction 1/6, how do I get from 6 to 24?
Times 4.
Times 4. Well, whatever I do to the bottom, I have to also do to the top. So 1 times 4 would be 4. Now that I have my denominators matching, I have my new numerators. I have created equivalent fractions for my original ones. I can add my numerators together. So when I add my numbers, I end up with 7/24. Okay, we're going to practice finding the LCM of the following pairs below. So I have 2 and 4. I have 8 and 5, 4 and 6, and 3 and 4. I want for this yellow table and blue table, y'all are going to do the 2 and 4 box. This back table and my peach table, y'all are going to do 8 and 5. y'all are gonna do 4 and 6, and then teal table, y'all do 3 and 4. You're only doing one box, okay? I just assigned you the one that you're doing. So you're only doing that one, and then we will check. Okay, so everybody just shared what they got for their least common multiple. For each of the assigned boxes that they were supposed to do. So yellow and blue table told us that after they listed all of their multiples, they had an LCM, least common multiple, of 4. The purple and the teal table, peach table told us that after they listed their multiples for 8 and 5, 40 was the least common multiple. Checkered table told us that 12 was their least common multiple, and teal table said that their least common multiple was also 12. Okay, we're going to do a couple of definitions real quick at the bottom. Common just means shared or same as another. And multiple is the number multiplied. So, in other words, skip counting. Next, we're going to talk about GCF. What does GCF stand for?
Greatest common factor.
Greatest common factor. Anything you don't get right now, you can always go back and watch in Google Classroom to fill in or get from a friend. So don't panic if you don't get it all, because you can copy it down later. We're going to go on to the next page, which is lesson 36, called Greatest Common Factor. So there's a couple ways that you can do greatest common factor. The most common is probably like a T-chart. Sometimes I call this the horseshoe method. It's when you have your factor, and together they make the product. So what we would do if we're using the T-chart method is we would list all pairs of factors. We need to list all pairs of factors. So the first pair is always 1 and the product, because 1 times any number is the same, right? So if I'm trying to figure out the greatest common factors of 2 different numbers, it's always going to start with 1 and whatever that number is. Then I would try 2, 3, 4, and just keep going. Okay, remember the divisibility rules. We've done this. You can go back and look at your divisibility rules earlier in your journal if you need to. If a number is already listed or is a twin, then we stop. That's where that horseshoe comes in, and it starts to loop back around. Okay. So what we're going to do is use a T-chart to list our factors. Common factor is a number that is a factor of 2 or more numbers. So that's what we're looking for. We're looking for all of our common factors. So if, for example, I have 4 right here, then I want to list my factors that would make up 4. All of my pairs, starting with 1 and 4. And then what would I do next? 2 and 2. And if I kept going, then it would be 4 and 1, but that loops back around. So it kind of does this like horseshoe method, because then I'm back to 4 and 1. All right, so that's where I stop. When I look down here, 2 times 3, if I were doing, I don't understand where that came from. Oh, I guess if I was doing 6 and 4. No, I don't know where that came from. We're going to come back to this because I don't know where that's coming from yet. Okay, let's look at some more examples. We have 36 and 48. I want to find my common factors of these 2. And then I'm going to find my common factors of these 2. So we're going to start with the one on the left first. Okay, we can start by doing a T-chart. So we're going to list all of our pairs that we know make 36, starting with 1 and 36. Then we'll go to 2. 2 times what makes 36? Say it again. 18. And then 3 and 12. And then 4 and 9. And then 5 can't, because 5 doesn't go evenly into 36. Can 6 and 6. Okay, and that's where it starts to loop again. I know 7 can't, 8 can't, but then it would be 9. I already have 9 and 4 paired up right here. Okay, let's do the same thing for 48. Starting with 1 and 48. Then 2 and 24. 3 and 16. Remember divisibility rules. If I can add these two numbers together and it equals a number that I can divide by 12, 4 plus 8 is, 3. When I add these together, it makes 12. 12 can be divided by 3, which means 48 is divisible by 3. Okay, then 4 and 12, not 5, but 6 and 8, not 7. If I kept going, it would then be 8 and 6. That's where it loops around again. Okay. Now, that is T-chart method. Could you list out your factors as well? Yes, you could. You could list out, we're going to do a list method. 1, 2, 3, 4. Sometimes this is what I do.
I declare a thumb where.
I typically will list out all of my factors. I don't need to put 6 again. I can then just start. I can keep going. So those are all my factors listed out. For 48, I can do the same thing. Just list out all of the factors that I know make 48. And then I want to find my common factors. So I can either, depending on what method you like best, if you like the horseshoe or the T-chart method or the listing method, you go back and you find all of your common factors. So up here, I have 1, 2, 3, 4, 6, 12, and that's where it stops. So my common factors are 1, 2, 3, 4, 6, and 12. But my GCF, my greatest common factor, is 12. Okay, we'll do the same thing for 21 and 35. This time I want you to try it. You can work with your group on this one, and then we will check it. You're gonna do both, the T-chart and the list.
So the greatest common factor would be 5.
Okay. Okay, so your factors for 21 should be 1, 3, 7, and 21. Your factors for 35 should be 1, 5, 7, and 35. Your common factors are 1 and 7, but the GCF is 7. Okay, let's go down to the bottom. We're going to find the GCF of 4 and 8. My factors for 4 are 1, 4, 2, and 2. My factors for 8 are 1, 8, 2, and 4. T-chart method. List them all out. I have 1, 2, 4. I have 1, 2, 4, and 8. Now I will identify all of my common factors. So I have 1, 2, and 4. But the GCF is 4. Again, GCF is how I can reduce fractions to make them in simplified format. So anytime I tell you simplify fractions, all of our fractions moving forward should be simplified. That's how you do it. You find the GCF. That's what you divide both numerator and denominator by. Okay? If you just reduced by a common factor, then you have to go in multiple steps. Then you have to reduce again. So if you have, for example, like 24/50 seconds, okay? Something like that. Yes, they're both even. Yes, I can divide them by 2, but is it the greatest common factor, or could you reduce by even a bigger number? Because if you divide by 2, then you may have to reduce it again, maybe by 2 again, but you have multiple steps versus just 1. So GCF will save you time if you can identify that greatest common factor and just reduce once. Okay.